Lithium-ion batteries are the conventional and state-of-the-art technology for portable energy storage. Shown here are the components of a lithium-ion battery. The mechanism involves reversible redox reactions between the cathode and anode, with lithium ions dissolved in organic electrolyte that diffuse back and forth between the two electrodes for charge balance. Generally, the cathode component limits and dictates the overall performance of the battery, and thus is the focus of my work. Historically, lithium-ion battery cathodes were primarily comprised of cobalt, but this has changed in recent years. In fact, it is preferable to eliminate cobalt entirely from the cathode, as this material is scarce, expensive, and has a monopolistic supply chain. Specifically, modern cathodes are comprised of a solid solution of nickel, manganese, and cobalt. The trend in both industry and academic research alike is to increase the proportion of nickel. This is regarded as the most promising path toward cobalt-free batteries. By increasing the nickel content in the cathode, this can generate higher charge storage capacities, as seen on the two graphs on the left. However, there is a very severe cost in the cycle stability and lifetime of the battery, as seen on the two graphs on the right. Now, there are many reasons for this as listed here, most notably mechanical degradation, side reactions with electrolyte, and phase changes in the lattice structure. While the challenge of discovering a new class of materials with excellent performance is a difficult and unpredictable process, what's more practical and promising is to simply improve on existing materials. In general, we can improve on cathodes by 1. Changing the particle morphology. Now, one notable example of this is how single crystal particles can mitigate mechanical degradation compared to conventional polycrystalline particles. Number 2, applying a metal dopant which can suppress phase changes in the lattice structure. And 3, applying a surface coating which mostly helps to suppress side reactions with a liquid electrolyte. Number 4, a more drastic measure we can take to mitigate these side reactions is to replace the liquid electrolyte with a solid-state one, although there are still significant performance hurdles to optimize this technology. While lithium-ion batteries are a critical technology to help reduce our reliance on fossil fuels, the sustainability of its production is equally as important, in which I hope my research can help address.